Hi everyone, welcome to this continued series on understanding data or sense of data and the various pre-processing techniques. In the world of data science and machine learning, having a good understanding of appropriate data processing steps is very crucial. So in the previous few videos, we covered quite a bit of topics, starting with data types and feature types, general inspection of data quality, how do we handle duplicates, missing value analysis. In fact, we had two videos on this particular topic, handling outliers, cardinality assessment, and then encoding of categorical data, scaling and normalization. We also covered data imbalance. In this particular video, the last topic that I'll be covering is data splitting. Now, this data splitting is for preparing the data for building machine learning models. And we will look at few splitting techniques that are used in most of the machine learning or deep learning projects. So data splitting is a fundamental step in the machine learning pipeline, and that involves how to divide a data set into distinct subsets for building the machine learning, evaluating the model, and testing the model. We'll understand intuitively what is the reason for dividing the data set. This data set means the training data set. This process is very crucial to develop a model which is well functioning and generalized. That means it works most of the time, even though the data quality or data changes over a period of time. The primary motivation behind data splitting is to have a balance between the model training and the prediction, essentially evaluation. So thereby we achieve prevention of overfitting, and we enable a model which is more realistic in nature. So let's get started and see what are the various splitting methods available in Python. So various types of data set that we use in machine learning. So training data set is the purpose of training data set is to train a machine learning model. So if you have a data set of size of 50,000, let me just take an example here. So let's say our data set DB is 50K, and out of 50K, we will reserve about 80% for building the model. Probably 10% we can set aside to validate the model. So now this training process and validation typically goes in a cycle. We will talk about it when we discuss machine learning process flow, and you will see how we build machine learning models in an iterative manner. So when we do so, we will train the model using the training set and then continue to evaluate or validate using the validation set. So once the model is trained and is ready for, let's say, some kind of testing, major testing, not normal testing, but something like a, the major phase N testing or something, or ready for production, probably, maybe we are at that level. We are pushing the model for prediction of production, or we need to evaluate whether it is ready for production or not. Then again, we can use remaining 10% of the data for the final testing. Now, these strategies are not really cast in stone. Different organizations have different mechanisms to train and validate and also test at the end. You could completely build the model exclusively for training and exclusively for validation or testing. You could have different departments or different projects creating those data sets. So there is no hard and fast rule, but just to understand the basics of machine learning model building process, I'm going to walk you through making an assumption that we have a common pool of data, and out of that we will take 80% for training, 10% for validation, and the remaining 10%. Now these percentages are also not really fixed. I mean, you can go for 70% and 20% here and 10% here and so on and so forth. Okay, so splitters and operators, these are functions available within Python to help you split the training data in different ways. And we will talk about those different ways. What are the typical ways you evaluate or test a model or a machine learning model? The first method that we have is called, random test. I'm going to walk you through each of the types here. I've listed only 4 types, so 1, 2, 3, and 4. But there are many other types of evaluation as well. So let's talk about each one of them. Random test, leave one out, cross validation. We'll also talk about the meaning of cross validation, train test split, and k-fold cross validation. Don't worry about it. I'm going to show you the meaning and a concept, and also I'll show you Python code demonstrating the outcome of each of the type of um, the splitters. Now these splitters are nothing but functions, and they split a data set. Okay, so why do we do so? The splitting, let's take a simple, first method. And this method is called random test, which is very common sense. Let's say this is our machine learning model, some model, and this is my data set, and data set has 150 training samples. We can use all of the 150 samples to train or build the model. And then we come up with our own test sample. Let's say, a random test, and we can build our testing data one row at a time. Okay. And that row, we are asking the model to predict. So what are we asking the model to predict? We are asking the model to predict the class or the outcome. This is called Y in the language of machine learning. And these columns are called X. So what we have passed to the model is randomly generated sample called X test. It could be any name, but I'm just using for easier understanding. So this is X test, this is one row, and we are asking the model to predict. So we're getting some prediction. Prediction is denoted by something like this in AI. So let's say our model, the first time we ask the model to predict for this sample, and we get some prediction here, and second we ask for this one and we get some prediction, and some prediction, and then we know the actual value. So when we ask the model to predict, we have an idea that the model should say, this is Virginica or Setosa or Virgin, or any other class, and then we go through the evaluation purposes. Now, so this is called random test, means we are passing our input data one at a time. So this is called the random evaluation of the model. For this, we don't need any splitter as such, but just generate the data randomly. Now, leave one out cross validation is also called LOOCV. Let me walk you through as to what this is. LOOCV, leave one out cross validation. So this is my model here. It could be any model. I have given KNN. It could be anything, any model, doesn't matter what it is. And let's say this is our data set, and that has 150 samples. Then leave one out means I'm going to take one sample out of this 150 and remaining 149 I will ask the model to use for the training purposes. So here I'm using 149 samples. Now, after the model has been built or the model has been created here, I'm asking this sample that we took out of the training set. We are asking the model to predict for this sample. So we are going to pass the input data, which is basically this input data, which is basically X or X test. Now for this X, we already have the Y here. All right, so Y means the label. So let's say this flower and this label is known to you. So you're asking the model to give you a prediction, and the prediction is Y hat. So essentially, what we're going to do is we will compare Y versus Y hat. Let's say the actual and the prediction. The actual is 0 and the prediction is also 0. Now leave one out. Cross validation means is going to work in loop. So means the next time. So this is basically a loop. So next time it will leave the other row in here, and then again the model will be trained with 149 samples, but this 149 is different than the previous 149. So the one that you left out is the other row, which is a row number 148. Okay, so this is row number 148. Now we are asking the model to predict. Let's say the actual was 1, the model is also predicting as 1. And likewise, so since this is a loop, so this will go on for all the samples, and essentially you will have 150 comparisons. So here the actual is whatever, okay, and then the model comes back with predictions for each of the cases. Now, what we can do is compare. So out of 150 comparisons, let's say we have 140 times it was correct matching of y and y hat. So the accuracy of the model is 14 by 15. So this 14 over 15 will give you some accuracy close to whatever, 90% or something. Now, so this is leave one out. So we got this part here. So what is cross validation? The cross validation, the idea of cross validation is we are actually taking one from the training sample at a time, and then we are validating one at a time by training the model. So let's say first time we trained the model, then tested the last one. And after that, in the second run, we tested this one. Then we tested this one, and then we tested this one. This idea of testing is called cross validation. So basically, using the training set, we are training the model, and at the same time, one sample from the training set we are using to validate, and that's called cross validation. This method is called leave one out cross validation. Now the problem with this method is going to be very time taking. Let's say you're going to if you have 50,000 samples in the training set, so the model build, you will build the model 50,000 times, and then the prediction is also 50,000 times. All right, so this is going to be pretty computationally very heavy. Let's look at the next one. So do we use leave one out cross validation regularly? Not really regularly. We use it occasionally, like when we are very sure about the model and the model performs reasonably okay, and a model is substantially built with a good amount of diligence and so on and so forth, then you apply leave one out cross validation. The advantage of leave one out cross validation is very um, is very comprehensive because you're testing every sample against the remaining sample, but that particular one. So this method is very, very solid method. That means the result that you get is trustworthy. But again, time taking, so we don't use this regularly during the development cycle. The method is next method is to call holdout method. The other name to this method is also called a very popular method is called train test split method. So in this method, what we do here, we have a training set, let's say 150 samples, and we divide it into split, and that split is mentioned as percentages. Let's say this is 30%. So out of 150, 30% will go as validation, and remaining 70% we will use for training. So we will use the 70%, which is about 105 samples for training the model. The model has been trained, and then we can take the testing sample 30%. That means that is going to be 45 of the samples. These 45 samples we will ask the model to predict. So for each of the sample, the y is known. So we're going to get y and y hat again. And then we compare. Let's say this is how the actual is, and this is how the predictions are. Again, you're going to compute out of 45 times, let's say 42 times, it is correct prediction. So that gives you the accuracy of the model. So this method is light. I mean, it doesn't iterate, and you basically take a chunk of data and train with the remaining chunk, and test the model in terms of performance. So this train test split is used quite often. So now let's see one more method, and that's called k-fold cross-validation. This is again one of the most popular and also computationally very heavy splitter or splitting method. So in this, what we do is somewhat a combination of leave one out and train test split. So this is our data set of 150 sample, and the k is number of split that you want to make. Let's say k is 5. So this 150 sample will be divided into uh, you know 5 parts. Then what we do with just one part here, so one part is 30 samples, and then the remaining 4 parts is 120 samples, and we train the model with 120 samples, and then we test it with this particular 30 samples to see how the model is giving the results. So you have y hat, and this is split number 1, and split number 1 has 30 such results, and then you have an accuracy, let's say 81%. Second split is taken, and the remaining, all these are used for training the model, and the second split is again used for testing the model. So this is split number 1, then split number 2, and again you have those 30 samples in the second split, and let's say the accuracy is 87%. Likewise, you will do up to split number less, the last split is 5, and again those 30 samples in that particular split, let's say the accuracy is 91%. Now final accuracy would be the average of all of these accuracies. So this method is called k-fold cross-validation. You folded the data set into k parts, and then you applied cross-validation is quite similar to what we saw in the leave one out cross-validation and train test split, almost the same. But again, this is very heavy um, because you're going to do, so many, five splits means 5 times you have to train the model, and evaluation is also 5 times. But the result is pretty uh, trustworthy here. You have a better trust with such cross-validation methods. So do we use k-fold cross-validation all the time? No, not all the time. This is also used occasionally at the end of it, or maybe at the end of maybe like a weekly cycle or maybe a fortnightly cycle. Practically, we use k-fold cross-validation, or when the model is completely built and is ready for production push, we use k-fold cross-validation method. I'm going to show you the Python implementation of these splitters as well. I'm not going to do a machine learning demo because we haven't covered machine learning yet. But these are the splitters here. What we have covered so far, let me highlight here. So we have covered the k-fold, we have covered leave one out, we have covered, now these are all variations of the same thing, okay, same k-fold. And likewise, you have leave p out, which is again a variation of, you know. So I'm going to show you some of these in the Python code and utilizing these splitters, and I'll show you some with some dummy data how those splits actually look like. So let's look at the Python demo on data splitters in scikit-learn. So let's look at one by one here. The first method is leave one out cross-validation method. I'm going to be using dummy data. So let's run this. This package is within model selection, leave one out, and some dummy data, 2 columns data, and binary target column, which is a response column. Combine these two like a table. So this is how the data looks like. Now I'm going to do leave one out. So instantiate the object, leave one out. And then after that, I'll do a split of the data set using leave one out means every time is going to leave one sample out. And then we can visualize what are my training samples and what are my testing samples. This is simply, to demonstrate. So the first time it took these as training samples, and the testing sample is the index number 0. Second one, notice the index is 1, which is not part of the training. Similarly, this one is the third split, and notice the index is 2 for testing, which is not part of training. And likewise, you have those 20 combinations. So you're going to run the model 20 times and evaluate 20 times. So this is called leave one out cross validation. Second is the variation of the same leave one out cross validation, and is called leave p out. So leave p out. P means proportion. So instead of 1, we can say leave 2, leave 3, or leave 5, whatever that we want to do. So again, the same set of column. Combine these 2 columns like in a data set. And let's say I'm saying, okay, 2. Okay, so he's going to leave 2 out or 3 out. Okay, so depending on what you want to do, perform leave p out, call leave p out function. And let's say I'm going to see this split only the 3 times uh, because it's going to do lots of combinations of the data. So this P is a proportion means any two, right? So let me explain. This is really heavy. Let's say you have 150 samples and then we are taking 2 at a time. This could be any 2, okay? So any of the 152, and there can be many such combinations. So you can imagine what is the number of combinations that you're talking about here. So 150 divided by 148 and 2 factorial. So that many combinations we are talking about. 150 multiplied by 149. So that many times the model is going to be trained. Imagine, I mean, that's pretty heavy. So leave P out is used very occasionally, very rarely, and unless you have a cluster of machines where you can parallelize your training process or evaluation process, we don't use leave P out. Okay, the third method is train test split. Quite easy. Again, dummy data and combine them. Now I'm saying here, train test split is pretty easy to understand. Here is my X and this is my Y. And I'm saying test size is 30%. So what does it mean? What it's going to do is, let's say this is my data, 2-column data, X, and this is your Y. And I'm saying split, train test split. So it's going to split it 20%. So this is like 20% here, 20% here, and 80% here, and 80% here. So essentially, it's going to divide these two arrays, which is X and the target, into these parts. And this part, the first one is your X train. And then second return that you see is X test, which is this one, X test. And the third one is Y train. So this is Y train, which is basically this one. And the last one is Y test here. Okay. All right. So this is very popular and very commonly used in machine learning and AI. Any of the AI project, including reinforcement learning, deep learning, and all of those here. So you see here, I'm dividing the data into split 30%. So 20 total number of samples. So 30% of um 20 is 6. So in the test, you will have 6 samples. In the training, you have 14 samples. So this is called train test split. Let's look at one more, which is a k-fold. So again, this is part of model selection. Use k-fold, data is the same, combine them. Now I'm saying fold is equal to 3. That means I'm going to divide the data into 3 parts. Okay. And then I'm saying I'm going to run it a few times. Okay. So it's like, the k-fold itself, I'm going to run a few times. Okay. So train test split and not train test split. Now I'm splitting the data by using a k-fold, and then that will return my training data and the target, and testing data and the target. And you can take a look at it here. So this is a fold number 4, fold number 5, fold number 6, fold number, and so since this is 3, so we gave a 3 parts of the data set. So when we talk about machine learning, we will see how we actually use them in the context of machine learning. So this was just to show you the output of the split so that you're more comfortable with the idea of split. When it comes to machine learning, we simply use the machine learning models and we provide the splitter. Only this is passed. This is not really used. This was used only to demonstrate in the machine learning models. We pass this object KF, and that will take care of the split for us. So that's pretty much the coding or the insight about the splitting methods. Okay, so we completed our discussing the splitters in scikit-learn, like namely train test split, k-fold, and leave one out, leave p out. There are variations of all these also. There are 5, 6 additional variations of the same available in the scikit-learn. So that's pretty much we had in the playlist for pre-processing. We'll see you in the next video or next series of videos. Have a great day.